So we're continuing on in section 8.1 part 2, and now we're going to make a decision to either reject the null hypothesis or fail to reject the null hypothesis. So depending on the method that we chose will determine how we figure that out. So if we are using the p-value method, we'll reject it if it's less than or equal to the significance level. And a good way to remember this is if the p is low, the null must go. And then we fail to reject if it's greater than. So we've got the same information here. The significance level is 0.05. The p-value found in that calculator was this. Make a decision to either reject the null hypothesis or fail to reject. So we want to know, how does the p-value, is it less than or equal to the alpha? So is 0.005 less than or equal to 0.05? And if you're someone who has difficulty with this, start by looking at the first digit. They're both 0. And then the second digit, 0, is less than or equal to 5. So we would reject the null hypothesis based on that criteria. Again, if it's less than or equal to alpha, we reject. So now when to reject for the critical value method. Remember, we drew our region based on where the type of tail test, and then we found our critical value and we looked at where our test statistic was. The critical region is where we reject. So if the test statistic falls into the critical region, we reject the null hypothesis. So this was the image that we drew before. And remember, we saw that our test statistic was like 2.55, right? It was inside of the critical region. So we would decide to reject the null hypothesis. So p-value, critical value should get the same answer, but just so you can see how that works. Now, the last part is very important, and it's restating the decision using simple and non-technical terms. This is very important. Writing this down somewhere, having this handy, you'll definitely want this on your cheat sheet. But so you basically go through this situation. After you decide if you reject or fail to reject, you want to look at these conditions and then determine the conclusion. And this is why we wanted our original claim in symbolic notation. We want to make sure we remember, does it include equality? And that will help us with this here. So it's a little bit confusing, right? Accept, we don't say we accept it. We say we fail to reject. And that's because accept is misleading. It implies inaccurately that the null hypothesis has been proved, but we cannot prove a null hypothesis. Fail to reject just says that the available evidence isn't strong enough to reject it. And so accepting and failing to reject are different things, and it is important that you use that language. Now, the language is confusing. It's got multiple negatives. So just, we like to restate them using those final conclusions. And we'll do an example here. So we're still in this same example here. We've done the p-value method and the critical value method. We decided to reject the null hypothesis. So now we need to restate it in non-technical terms. So the first thing we need to determine is, does the original claim include equality? And this was the original claim, and it does not include equality. So let's go back here. The original claim does not include equality in these two here. So we're not even going to look at these for this example. Now, what did we do? Did we reject? We then rejected the null hypothesis. So we rejected it. So this is the statement that we're going to use. We're going to say there is sufficient evidence to support the claim that. So we're going to say there is sufficient evidence to support the claim that, and then what was our claim? The majority is uncomfortable drone delivery. Forgive my terrible handwriting here. Now, the reason there aren't a ton of U-tries in this is because you're going to be doing a lot of U-tries in the next sections where we actually conduct hypothesis testing. But one very important thing that we do need to talk about is type 1 and type 2 errors. So a type 1 error is, we use the symbol alpha, and it's the mistake of rejecting the null hypothesis when it is actually true. And a type 2 error is failing to reject the null hypothesis when it is actually false, and we use the symbol beta for that. So a graphic here might be a little bit more helpful. a type 1 error, so let's say you reject, and the null hypothesis was actually true, that's a type 1 error. But if the null hypothesis was false, it was correct. And this is a helpful chart to help you here. So let's look at this here. This is a new example. They're claiming that a medical procedure designed to increase the likelihood of a baby girl is effective. So they're claiming effectiveness so that the probability of a baby girl is greater than 0.5. Given the following null and alternative hypothesis, so they gave those to us, and see here, the original claim is noted, write statements describing type 1 and type 2 error. So, sorry about that. Shouldn't be there. All right, so I'm going to make a note here that they're saying that the procedure is effective. That's the claim. And then this is saying that it's not effective. And this is going to help me when I make sense of this. So a type 1 error is when I reject the null hypothesis, but it's true. So what does it mean when the null hypothesis is true? If the null hypothesis is true, then it's saying that it's not effective. But I rejected it. What did I say? I said that it is effective because I rejected it. By rejecting the null hypothesis, I was essentially saying it is effective, but really the null hypothesis was true, which is it's not effective. That's a big deal. If I say something's effective and it's not really effective, that's a big error. Type 1 errors are more commonly considered bigger errors. Like type 1 errors are bigger deals than type 2 errors. So let's make sense of this. So if we fail to reject, and the null hypothesis is false. So let's start with the null hypothesis is false. If the null hypothesis is false, then the null hypothesis is not effective. If that's actually false, then it is effective. But if we fail to reject it, that means we'll just say for a second that we accept it. So we say that it is not effective. So that's when we say it's not effective, but it is effective. That would be the type 2 error. And that's less harmful if you say something is not effective, but it was. I mean, it's harmful if it's a very important drug procedure or something, but I think it's, in general, it's more dangerous if we say something's effective and then it's not. If you'd like to read a little bit more, here's 2 slides. You can pause them. And then you go ahead and give it a try in 31 and then press play when you're ready to see the solution. And that concludes 8.1. We'll apply these. We'll actually do the p-value and the critical value method in sections 8.2 and 8.3 with lots more examples and lots more you tries.